All right, now that we have established our definition of the derivative, we're going to take a look at a particular application. We've been talking about one of the primary ideas that we'll understand the derivative as is that the derivative is the slope of the tangent line. So what we want to look at now is how we can use the derivative to determine the slope of the tangent line and thusly write an equation for that tangent line. So assuming that f of x is differentiable, that is to say we can find its derivative at x equals a, the tangent line to the graph of y equals x at a given point, P, with coordinates a, comma f of a, is the line through P with the slope f prime at a. We'll remember what two things do we need to know in order to write the equation of a line. We need to know the slope and a point. So if we know a point, all we need to know is the slope, and that's what the derivative tells us. And the derivative is f prime at a. So the equation of a tangent line, so this is the equation for the tangent line, is y minus, we're going to do this in slope form. So remember it's y minus the known y coordinate, f at a, equals the slope, f prime at a, times x minus the known x coordinate, a. So this would fall under the category of important formulas to remember for the rest of the course. If at any point I ask you, what's the equation for the tangent line at a given point, you'll all respond all together, y minus f of a equals f prime at a times x minus a. And you all said it together beautifully, right? And I can't write while I'm talking. This is the equation of the tangent line. Stuff it into your memories forever. When we get later in the year, we'll have memory quizzes on our trig function values, of course, but also on various formulas and things we have to memorize for the calculus of the course. So this would be one of those items that will be on those memory quizzes. All right, now that we know that, we can go ahead and do a problem where we actually compute the equation for the tangent line. So we know in order to write the equation of a line, we need to know the point and the slope. So we're going to find the point. It's going to be f at a comma f at a, and we need to find the slope f prime at a. So that's where we have to use our derivative. So let's go ahead and do this here. First of all, let's find our point real quick. I know that the x-coordinate is 5. How am I going to find the y-coordinate? Right, I'll plug 5 in. F of 5 will be 5 squared, right? Our function is x squared, and that equals 25. So our point, our known point, is 5 comma 25. Now I need to find the slope. We know that the slope is going to be given by the derivative at the point. So we know that slope is equal to f prime at the point we're interested in, f prime at 5. Well, now we need to use our definition of the derivative to figure that out. Up here, we've been talking about the definition of the derivative. We'll use our first one, that x minus a version. We said that f prime at a is the limit as x approaches a of f of x minus f of a over x minus a. So if we come back down here, we're looking for the slope at 5. That is the derivative at 5. That would be the limit as x approaches 5. 5 is functioning as a here, a comma f at a. And so we want the limit as x approaches 5 of f at x minus f at a is 5, over x minus a. All right. Remember, our function f of x is x squared. So then the limit at as x approaches 5, we know f of x is x squared, so we can just replace f of x with x squared. Minus f at 5, we know f at 5 is 25. And now we have a basic algebraic limit that we know how to evaluate. Of course, our first instinct to evaluate this limit would be substitution. When we substitute, let's see what happens. 5 squared is 25, minus 25 is 0. 5 minus 5 is 0, so that's not good. What should we do next? Good. We're going to factor x squared minus 25 is x plus 5 times x minus 5. And we notice right away there's a common factor. What do we do with our common factor? Cancel. So we're looking for the limit as x approaches 5 of x plus 5. Well, now that limit just became very easy to evaluate. How do we evaluate this limit? Good, we'll substitute. When we substitute is when we drop the limit. We stop writing it. We've actually evaluated the limit now, and we see that the limit is, in fact, 10. This value 10 is equal to f prime at 5, which is our slope for our tangent line, all the way back to the beginning now. We were looking for the equation of the tangent line of f of x equals x squared at x equals 5. What two things we need to know to write the equation of a tangent line? We need to know the slope and the point. We have a point right here. There's our point P. We have our slope right here. It's 10. Now we can write our equation of the line. The equation of the tangent line is y minus the known y coordinate, 25, equal to the slope, right, f prime at 5 going in there, times x minus the particular x coordinate. There is our equation of the line. Ding, ding, ding. Y minus 25 equals 10 times x minus 5. You're welcome to, if you'd like, to go ahead and simplify that down into slope-intercept form. Right, we would distribute the 10, we get 10x minus 50. Add the 25 to both sides, y equals 10x minus 25. Both answers are completely correct. Neither is better. Both will receive full credit. But this is how we can use the derivative now to actually find the equation of a given tangent line. We use the definition of the derivative to compute the actual derivative value, which gives us the slope of the tangent line. Then we just use our regular point slope form of the line to write the equation.